Hello and welcome to Honors Function. In this lecture, we're going to review inequalities, more precisely, polynomial inequalities. It will help us understand a type of local behavior that we will study in the next two lectures. Let's begin. Let's start with example 1. We have solved this type of inequalities before. We are going to draw a sign chart to find the solution set. Okay, so here's the first row. It represents the real line. It goes from negative infinity to positive infinity. Here in this column, I'm going to write the different factors. So here's a factor, 2x. I don't really need to write the 2, but let's write it anyway. Here's another one, x minus 1. And then we have 2x minus 3. And then we have x plus 2. And finally, the expression we want to study, which is 2x times x minus 1 times 2x minus 3 times x plus 2. Okay, then on the top row, we need to write the different values of x that will make all the factors equal to 0. So this is equal to 0 at 0, this is equal to 0 at 1, 3/2, and negative 2. Okay, we need to write this value in order. Negative 2, 0, 1, 3/2. Then we draw a line right below each values. Like that. Finally, I'm going to write the zeros on top of the line. So 2x is equal to 0 when x is equal to 0. X minus 1 is equal to 0 when x is equal to 1. 2x minus 3 is equal to 0 when x is equal to 3/2. And x plus 2 is equal to 0 when x is equal to negative 2. Here we go. I'm going to report these values in the last row. And finally, I'm just going to fill in the signs. So here it's going to be negative, positive, positive, positive. Here it will be negative, 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 positive, positive, negative, 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 positive, and negative, positive, 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 positive. And finally, I'm just counting my negative signs. 4, so I have a plus. 3, I have a minus. 2, I have a plus. 1, I have a minus. 0, I have a plus. If you have an odd number of negative signs, you will have a negative sign in the end, okay? And then we just write the solution set. So I want to know where it's strictly above 0, here, here, and there. So the solution set is x has to be in negative infinity, negative 2, parentheses, right? I cannot make it equal to negative 2 because it's a strict inequality. Next set is 0, 1. And finally, we have 3/2 infinity. All right, so this is a recall on how to draw a sign chart to solve an inequality. Let's go over another example now. So let's solve this inequality. Now, this inequality is a product of how many factors? 1, 2, 3, and 4. I'm not counting, there are 2 factors there, right? X plus 1 times x plus 1. So there are 4 different factors. So I should write in my sign chart 4 different rows, right? X goes from negative infinity to positive infinity. And then I should write negative 3. That's one factor. Then x plus 1 squared. Then x squared minus 2x plus 5, and finally 4 minus 3x, right? And then at the end we would have the expression. So I don't want to write it, I'll write expression. Okay, negative 3, this is not something I can just leave out because it's always negative. It's never going to change sign. It's not going to switch from negative to positive. It's always negative, and so we have a line of negative sign. And negative signs is what I'm counting at the end to figure out the final sign right here in this row, right? So the negative signs are very important. If instead of negative 3, I had plus 3 right here, I'll change it back, okay? If I had just the 3, then I don't need to write the 3 here because it would just be positive, and a positive row does not change the sign of my last row at the end, right? So I wouldn't need to write it, but because it's -3, I need to write it. So my first remark is, be careful, guys. If you have a negative factor, a constant negative factor, you need to write it in the table. Second, look at this factor. This factor is x plus 1 squared. No matter what, x plus 1 squared is always positive or equal to 0. Here, I'm going to have a line of pluses, right? So, do I need to write it? Well, we're going to have to be very careful here. So, you would have a row of pluses, but if x is -1, you would have right here a 0, right? And because your inequality is large, you would have to spot that -1. So it's up to you if you write it or if you don't write it, but make sure if you don't write it, you're going to write the -1, okay? I'll show you what I do. And then finally, let's look at this factor right here. This is a quadratic factor, so the first thing I'm going to do is try to figure out where it's equal to 0. So let me try to solve the equation. X squared minus 2x plus 5 equal to 0. I know how to solve that. I'll complete my square. X minus 1 squared minus 1 plus 5, that's plus 4. And so we have x minus 1 squared equals -4. So what does that mean? It means that this quadratic equation has complex solution, right? So it means that the graph is either always above the x-axis or always below the x-axis. Okay, now it's concave up. Right here there's a +1. So I'm in this case, the graph is always above the x-axis. Therefore, this is another line of pluses, right? It doesn't change the sign. All right, with that in mind, I should not have drawn my chart before looking at all the various factors here, because I don't need to draw such a complicated chart with all of these different factors. I'm going to draw a simpler chart. Let's see what's going on here. How can we do that? All right, here we go. So I have x right here going from -infinity to +infinity. I will put my -3 because that's a negative sign that will change my sign at the end. I'm not going to write this one. I don't need to. It's always positive. I still need to write -1 here, right? This one is always positive. I don't need to write it, right? This is always positive. It doesn't have to go. So the only factor I have to write is 4 minus 3x. That's it. And 4 minus 3x changes its sign. It's equal to 0 when x is 4/3. Here we go. Like that. Right here. Okay. And then the expression I'm studying is this one, -3 times x plus 1 squared times x squared minus 2x plus 5 times 4 minus 3x. Here we go. So I know this is equal to 0 here and also here. -3, well, that's always negative. It doesn't change sign. And 4 minus 3x, well, if you think of a line, it's a line going down, right? So it's going to be positive before the 0 and negative after the 0. Here's a 0 right here. Positive before, negative after. So I have minus, minus, and plus, right? So I want to figure out where this is positive or equal to 0. So it's going to be positive or equal to 0 if x is in 4/3 infinity, or, and this is why you cannot forget this one, or at -1. That's it, okay? So this is an example of a sign chart where you may not have to write all the factors in your polynomial. Some factors are always positive, and you don't have to write them in there, okay? Because a line of pluses does not affect the last row in the end, okay? You just have to be careful though. If it makes your expression equal to 0 and you have a large inequality, then you have to pick up these values, okay? Let's go over another example now. Okay, so I'm gonna do example number 3, and then you will finish all of the examples in this lecture, which is, you'll have to do example number 2, 4, and 5, please, okay? So example number 3, my inequality is strict, right? It's strictly above 0. So this right here, I don't need to write this factor in my sign chart because first of all, it's always positive or equal to 0. And I don't even care about negative 5/2 because I don't want my inequality to be equal to 0. Okay, so I'm not going to write that. Therefore, I have only two factors. I have negative 2x. Okay, I could have separated like negative 2 and x's, but why? I can just write negative 2x right here, x, and then the other one is x minus 1. That's it. And that's going to be enough to study the whole expression right here. So we have negative 2x times 2x plus 5 squared times x minus 1. Here we go. Going from negative infinity to infinity. So therefore, there are two values that I'm interested, 0 and 1 right here. 0 for this factor, 1 for this factor. This is negative 2x, the line goes down, so it's positive before, negative after. This is x minus 1, the line goes up, so it's negative before and positive after. Negative, positive, negative. Here we go. It's very, very quick. We want it to be positive, so the solution set is x has to be in the interval 0, 1. That's it. Okay? All right, this is a short lecture. Thank you for watching.